Okay, so let's take a closer look at an example reaction. So let's suppose we have silver nitrate solution and we put some copper, solid copper into it, okay? What we're going to get out will be silver, pure silver, and copper nitrate. Now, before you say anything, I know this isn't balanced, and it doesn't need to be balanced yet. By the time we're finished, it will be, but don't balance it right now. Just try to cope with the way it is. So the first thing you have to realize, as I write this down, is this isn't really accurate. Hopefully you remember from chemistry that when you put an ionic compound in an aqueous solution, the first thing it does is dissociate. Do you remember that term? Dissociate. Dissociate means the two ions in the ionic compound separate from each other. They dissociate. They're like, I don't know you anymore. And they go their own separate way in the solution. So really, inside the solution, this would be Ag positive aqueous plus NO3 negative aqueous plus copper solid. And on the other side, Ag solid plus Cu2 positive aqueous plus NO3 negative aqueous. Now you'll notice I didn't bother to put but I guess I could. There's really two of them, but it's not balanced, so I don't really need to put that 2 there. Okay, for right now. All right, so here are our entities in the solution. Let's for a second just take a look at the silver. So we have an Ag positive ion on this side, and on the other side of the reactant sign, we have a silver solid. So what is happening to this silver ion that it's becoming silver solid? Well, it must be gaining an electron, right? So now when we gain an electron, the overall charge on this side is 0, and it matches the charge on the silver. It's a silver ion becoming a pure silver metal. This is reduction. Right? The silver in the ion and the AgNO3 is becoming pure silver. This reaction is reduction. Now, if we were to look at just copper, it's Cu solid going to Cu2 positive aqueous. It's a pure metal going to a metal ion, or if we looked at the original, a metal compound. Now my reaction isn't balanced again, right? You have to have, remember from chemistry, you have to have the total charge on the reactant side has to be equal to the total charge on the product side. That's why we added 1 electron up there. But here, it's 0 on this side and positive 2. So I have to add 2 electrons on the product side. A pure metal going to a metal compound, this is oxidation. Okay? These two reactions, whoops, of course I didn't line them up very well. These two reactions are called half reactions. And one can add them together to get the full reaction that's happening here. Now, before we add them together, you might have to multiply one or both by some integer so that the electrons balance out and eventually cancel out. So here I'm adding 1 electron in my silver and I'm getting 2 out in the copper. So I'm going to have to multiply the silver 1 by 2. So it would really be Ag positive plus 1 electron going to Ag solid. And down here, Cu solid going to Cu2 positive aqueous plus 2 electrons. Should close my bracket. Now I can add them together. And so when I do, what I get is 2Ag positive plus Cu solid. And then if I wanted, I could put my electrons in, but look what's going to happen. I'm going to have 2 on this side, and over here I'm going to have 2. And in chemistry, you would have learned, if you have the same thing on both sides, just cancel it out. Okay, and then on my product side, I'll have 2 silver solid plus Cu2 positive aqueous. If I do a little check, 2 silver ion compounds, copper, copper, positive 2 charge here, positive 2 charge here, I'm balanced. Okay? Now, really what this is saying, oh, wait, I forgot all about the poor little NO3 negative. NO3 negative aqueous on this side, NO3 negative aqueous on this side. The NO3 negative hasn't changed at all. Okay? It is what is known as a spectator ion. It's just sitting there watching what's happening. It's not taking part at all. It's not involved. Okay? But the silver and the copper are. The silver is undergoing a reduction reaction. The copper is undergoing an oxidation reaction. And really they are half reactions, 2 halves of a whole. And that's why these reactions, they occur simultaneously, because this is showing you that the silver ion is gaining an electron, and this is showing you the copper solid is losing an electron. Well, silver can't gain unless something else loses, right? So reduction can't occur unless oxidation is also happening. And so because they're 2 parts of a whole and they occur simultaneously, the reduction and oxidation half reactions get called redox reactions, okay? Indicating that they need to occur together. Now, one loses electrons, that would be the copper, and one gains electrons, that would be the silver. And if you think about what are the reagents, so silver is, so no, let me start with copper. Copper is losing an electron, and the thing that, and becoming oxidized. So the thing that's making it oxidized is called the oxidizing agent. So silver is copper's oxidizing agent, not by accident. It is promoting copper to lose an electron because it needs one, right? So copper is being oxidized, so silver must be the oxidizing agent. Then if we look at silver, silver is being reduced. What is causing it to be reduced? The copper. The copper is the reducing agent. So the thing that's being oxidized is the reducing agent. The thing that's being reduced is the oxidizing agent. One will not happen without the other because one needs the other to happen. So a couple of little things. One is that then loss of electrons is oxidation, and gain of electrons is reduction. And the way you can remember this is L-E-O, Leo, as in Leo the lion, G-E-R, Leo the lion says grr. Right? And we all know he does because he's our mascot. So really, electrochemistry is really looking at redox reactions. Electrochemistry is looking at those reactions where there's an exchange of electrons happening, a transfer between entities. So if you go back to the electrochemistry page, first page of notes, under reduction, you should write it involves the gain of electrons. And under oxidation, you should write it involves the loss of electrons. There will be another line to go in there too, but that's the first line in each. So under reduction, write involves the gain of electrons, and under oxidation, write involves the loss of electrons. Okay, and we'll come back to that one more time. So for your practice tonight, it's going to be with these half reactions and balancing them, because in the end, this is balanced.